Welcome to Brain Vision.
Okay, so let's consider the change of state of ice to vapor. All right, to vapor. Now, in this process, we are going to consider two changes of state. So, ice will first melt and give us liquid, which is water, and then with further application of heat, or yes, let me put it that way, with further application of heat, it changes to what? Vapor. All right. So, if we want to consider the total heat energy involved in this process, let's say Q subscript T, that will be equal to the heat energy involved from changing from ice to liquid, which we are going to talk of latent heat of fusion in that process, plus the change from liquid state, let's say the change from liquid state to vapor, which is ml subscript V, okay, which is the latent heat of vaporization, plus maybe the temperature changes from negative 10 degrees Celsius all the way to 100 degrees Celsius, which will use MC delta T, okay, MC delta T. Now we're just going to take this one by one after the other, and so let's say when we pick MLF, latent heat, when we pick this, we'll have, let's say, Q subscript F, where the F stands for the fusion. So the mass of water, the ice is 12 grams. When you convert to kilograms, we have 0.012 kilograms multiplied by the latent heat of fusion of water, which is giving us 334 times 10 to the power 3. Okay, and when you solve, this should give you 400. Sorry, let me rewrite this. 4008 joules. All right, so that is the heat energy involved during the fusion process. Now let's look at the energy involved during the vaporization process. So it's the same thing, 0.012 times the latent heat of vaporization, which is also a constant, 2260 times 10 to the power 3, which is also equal to 27120 joules. Now, finally, let's look at the energy involved during the temperature changes, okay, from negative 10 all the way to 100 degrees. So here we are going to look at 0.012 multiplied by the specific heat capacity of water, which is 4190, into square bracket, we'll have, let's say, from 0 all the way to, from changing from negative 10 degrees Celsius all the way to 0 first, and then changing from 0 degrees to 100 degrees. So we'll have 100 minus 0. Okay, so this is what we are considering here. So this is what we are considering right here. Good. Now, when you calculate that, will also give you, we'll have 5530.8 joules. All right. Now, when we put all of this together, the total heat energy involved will be equal to 400 joules plus 27120 joules plus finally 55308 joules. So when you put all of this together, this should give you 3665.8 joules, which is also equal to, let's say, 36.7 times 10 to the power 3 joules. Okay, so this is what we get. This is the final heat energy involved, or that we have to give to the ice to convert it finally to vapor. Okay, now let's follow the sequence to change, let's say, change these joules to calories. Okay, to change these joules to calories. So in calories, we know that 1 calorie is equal to 4.184 joules. All right. So our 6.7 times 10 to the power 3 joules multiplied by 1 calorie divided by 4.184 joules. So we have joules here. This cancels this, and we are left with calories. And then this leaves our answer. This leaves our answer as what? 8.7 times 10 to the power 3 calories. Good. Now, once we're done with this, let's see how we can also convert it to British thermal unit. Okay, so in BTU, we know that 1 joule of energy is equivalent to 0.000947817 BTU. Okay, so this is what we get. All right, so our 36.7 times 10 to the power 3 joules multiplied by this, so which is 0.000947817 and divided by 1 joule. Remember, there's joule here. Then we have our BTU here. So this joule cancels this joule. This joule cancels this joule, and then when we multiply, finally, this gives us 34.75 British thermal unit. So this is our answer